Here we go, here we go, here we go. Where we stop, nobody knows. We need to get going, okay? You also need to make sure that you have this sheet out right here. Please make sure that it is out. You need one of these. Unit circle has the formula x squared plus y squared is equal to 1. If you recall, a circle has this formula, x minus h quantity squared plus y minus k quantity squared equals r squared. So definition of a unit circle is a circle that has that formula, x squared plus y squared is equal to 1, where your radius is equal to what? 1. What do you think it's centered at? What's the center? 0, 0. Very good. That's why it's called the unit circle, because it has a radius of 1 unit. Centered at 0, 0. The unit circle is a foundation by which we understand trigonometric functions such as sine, cosine, tangent, so on and so forth. It is imperative that you ingrain this in your brain. Now, with that said, the learning curve, at the beginning, it's kind of a struggle to push through. But, when you can get through the first 2 weeks, trust me, it gets better after that. But you really got to take this all in. All right, the other thing I want you guys to learn is this, is that the circumference of a unit circle is equal to 2 pi r. Circumference of a circle is 2 pi r, so therefore the circumference of a unit circle is what? Or 2 pi. Because the radius is 1, the circumference of a unit circle is 2 pi. So think about this, you guys. The distance around the circle is 2 pi. How many radians are in one entire circle? So that's what makes the unit circle interesting, is that the distance around is exactly the same as the number of radians in the unit circle as well. So the radian measurement and the length both match up. Confirm that the point square root of 3 over 2 and negative 1/2 is on the unit circle. So what I want to do is, you're going to have a few problems that we need to get through today. This is the first example. Confirm that this point is on the unit circle. Square root of 3 over 2 and negative 1/2. What quadrant would negative square root of 3 over 2 and negative, or a positive square root of 3 over 2 and negative 1/2, which quadrant would that be in? First, second, third, or fourth? Fourth, because you have a positive x and a negative y. So you don't have to draw this, but it would be sitting somewhere, say down there. We want to confirm that that point does in fact lie on the unit circle. How would I confirm that that point lies on the unit circle? Any thoughts? I will use my equation, x squared plus y squared equals 1. I will plug in my x value, I will plug in my y value, and go from there. So square root of 3 over 2, quantity squared, plus negative 1 over 2, quantity squared. See if that equals 1. What's the square root of 3 over 2, quantity squared? What do you get when you square 3? Square root of 3. 3. 2 squared is 4, plus negative 1 squared is 1, and 2 squared is 4. 3/4 plus 1/4 is 1. So therefore, that point is on the unit circle, because when you plug it in and square both and add them together, you do get 1. Any questions on that problem? Very good. Move on to the second one. Point P lies in the third quadrant, and the x-coordinate is negative 2/5. Find point P. So if I have a point down here, point P, and the x value is negative 2/5, tell me, will the y value be positive or negative? Negative. I'm in the third quadrant. Both x is negative and y is negative in the third quadrant. So if I want to find the y value, I can use the unit circle formula in order to figure that out. Namely that if I square the x value, negative 2 over 5, quantity squared, plus y squared is equal to 1. What is negative 2 over 5 quantity squared? 4 over 25 plus y squared is equal to 1. Subtract 4 over 25 for both sides. Y squared equals 1, which is 25 over 25, minus 4 over 25. What'd you say, Alex? 21 over 25 is y squared. Square root, the fraction. If you square root the fraction, you square root the top and the bottom. So I get y is equal to, can you reduce the square root of 21? No. So I have square root of 21 over 5. Square root of 25 is 5. Is that value positive or is it negative? The value is negative because I'm working in the third quadrant. Values are negative in the third quadrant. That will be a reoccurring theme for the remainder of the semester, because the square root is a positive or a negative. Any other questions? Could you do the first two problems if you were asked to? Okay. Now we move to the unit circle, which I like to refer to as the circle of life. Some people refer to as the circle of death. You get to choose how you want to look at things. The unit circle, as we just talked about, has a number of points that lie on it. We talked about some interesting points there. We talked about the square root of 3 over 2 and negative 1/2. We talked about negative 2/5 and negative square root of 21 over 5. I'm going to show you some more points that lie on there. Okay, the first points I'm going to show you that lie on there are the easiest ones. This point right here, if it has a radius of 1, would have the coordinate 1, 0. Coordinate up here would be 0, 1. Coordinate over here would be negative 1, 0. And at the bottom, 0, negative 1. Very good. Okay, so there's some points there. Now, we are going to fill out the back side of this sheet, all of the interesting points at interesting increments. So, for the very first one, 0. Now, you guys, after we get through the first couple, the rest are a lot easier, okay? So just, you bear with me till we get through like 60 degrees, okay? So 0, what is 0 in radians? 0. And if I have an angle of 0 degrees, which would be just like this, what coordinate does it go through on the unit circle? 1, 0. So my x value is 1, my y value is 0. Now we would like to do 30 degrees. What's 30 degrees in radians? Pi over 6. Very good. Hopefully that's something you started to commit to memory. 30 degrees is pi over 6. I go over here, and this is where you really need to focus in and just take a breath and, you know, enjoy this process. 30-degree angle intercepts somewhere up here at an x and y point on the unit circle. It is a 30-degree angle. A for the day. Who can tell me what the length of this line is? It is 1. How did you know that, Nathan? It's always 1. The radius of the unit circle is always 1. Always 1. I will drop down this altitude right here to form a 90-degree angle. Would you agree that the height of this altitude of the triangle would be my y value? Would you agree that the length of this triangle would be my x value? So if I can find this altitude of the triangle and the base of this triangle, I will have found the x and y values. This is a 30-degree angle. This is a 90-degree angle. That makes this 60. Does anybody remember the relationship among 30, 60, 90 triangles? Second hour wanted me to write this down, so I will. I don't know if this helps you. If it does, great. 30 degrees, 60 degrees, 90 degrees. If the shortest side is x, then the hypotenuse is 2x, or twice that value, and this would be x times the square root of 3. That's what they wanted me to write down. While I did that, I'll write down the other one, which is a 45, 45, 90 triangle. If this is x and this is x, then this is x times the square root of 2. Does that bring back some memories? We have to reference that now. That may seem unfair to bring that up at this time, but the ACT will do it to you in just a few months. And so will college algebra or calculus or anything else that you go on to take. This is stuff that hopefully stuck with you. If it didn't, we need to get extra help to work through that. But this is prerequisite knowledge. Okay, we're going to use that in this case right here. I have a 30, 60, 90. If the hypotenuse is 1, what will then that make the shortest side? 1/2. What will I do to that shortest side to get this longer side right here? Multiply by the square root of 3 to get square root of 3 over 2. So you can see that the x value is the square root of 3 over 2, and the y value is 1/2. If this is 30 degrees and this is 90 degrees, they need to add to 180, so that would make it 60. X is horizontal, y is vertical. So on the back side, I have, as I list here, square root of 3 over 2 would be the x coordinate. The y coordinate would be 1/2. Everybody follow along with that first one. We just saved 10 minutes. Great. Good job. Way to hang in there. You saw a good one. In all fairness, second hour does have 40 people, so that makes it a little bit different. So they did a very good job, but there was some confusion there. So they're going to watch this video tonight and hopefully see some more stuff. Now I'm going to move to a 45. If you want to draw another one, however you want to use the notes to your benefit is entirely up to you, okay? But you could continue to construct these if you want. You can see that this is a 45, 45, 90 triangle. And would you agree, again, that the bottom represents the x coordinate and that the other side represents the y coordinate, okay? The height. And once again, what is the length of this hypotenuse? 1. Now, if you look back at the 45, 45, 90 relationship among triangles, think about it, you guys. If I want to get the hypotenuse, I take the side and multiply it by the square root of 2. So if I had the hypotenuse, what would I do to get the side? Divide by the square root of 2. So that's what I'm going to do to this triangle. I'm going to take 1 and divide it by the square root of 2 to get this side. 1 divided by the square root of 2. Can you have the square root of 2 in the denominator? So I should multiply the numerator and the denominator by square root of 2. And you get square root of 2 over 2. That is the x value. What is the y value? Same thing, because it's a 45, 45, 90 triangle. We flip it over to the other side. 45 in radians is what? Pi over 4. And x is the square root of 2 over 2, we said. And y is also the square root of 2 over 2. Yes. In fact, we have used every single value. We'll get some positives and negatives in here, but these are all the values you'll use on the rest of the table. Exactly. So I'll show you, and life should be good for you. So let's watch. So now I will construct a triangle of 60 degrees. That would make this 90. That would make this 30. Tell me, what is the longest side? What is the hypotenuse? 1. What would that make the shortest side? Divided by 2 to get 1/2. What do I do with the shortest side to get this longer side? Multiply it by the square root of 3. 1/2 times the square root of 3 is the square root of 3 over. So my x coordinate is 1/2, and my y coordinate is the square root of 3 over 2. So 60 in radians is what? Pi over 3. X is, we said, the 1/2, and y is the square root of 3 over 2. 90. Look at your chart. What point does 90 go through on the unit circle? 90 is pi over 2. It goes through 0, 1. That was easy. These values will continue. I will do one more with you, then I'm giving you 10 minutes to complete the chart in class, and then we're moving on to the other problems. You're doing very, very, very good. Whitney looks at me crazy. It's going to go a lot quicker. I'll show you why it goes a lot quicker. Watch this example. 120 degrees. What is it in radians? Pi over 3. Very good. These are numbers we should, kind of commit to memory, be coming up with. Not a bad idea to, gosh, I remember in college getting together with people and doing vocabulary for our foreign languages, even when we didn't have tests, just to try to stay up with the stuff. It wouldn't be a bad idea if you're sitting in study hall to just spend 5 minutes and run through with somebody, test me on degrees of radians. It will help you all. I promise you. It's like knowing your multiplication tables. You will move more quickly through this class. I promise. So we have 0, 1. Now we want to do 120 degrees. Well, 120 degrees would be here to here. Okay? And if you notice, question. Very good. Yes. This point right here, x, y, it does, if you look, it makes a 60-degree angle here because 120 subtracted from 180 leaves me with 60 degrees. So once again, I have another 30, 60, 90 triangle. You will always have an angle of 0 or 30 or 45 or 60 or 90. That will always be the case. Here I have another 60-degree angle. What is the length of the radius? 1, or the hypotenuse and radius in this case are the same thing. What will that make the shortest side? 1/2, but which direction am I going? Negative. So it switches, the x value switches to negative 1/2. What will the y value be? Positive square root of 3 over 2 because I'm still going in the positive direction up. So in the third quadrant, both values will be negative. In the second quadrant, the x values are negative, the y values are positive. So as you look right now, as I go back to here, I have 2 pi over 3. That makes x. Very good. And y? Square root of 3 over 2. And this process continues. You have 10 minutes to try to work through this and get as many of these down as you can, and we'll move on to the remainder. Go ahead. All right, we move on. Okay, so you can check your answers against the unit circle that you provided for you, But again, you should understand that relationship of what's happening. And notice how the values repeat themselves. That's going to come up in trigonometry a lot. Now, example 3 says as follows. Find the terminal point on the unit circle determined by the following value t. Now, t represents t is length. Theta is angle. In the unit circle, they are the same. Okay, think about it for a second again. If I'm in the unit circle with a radius of 1, what is the circumference? 2 pi. 2 pi r is the formula for circumference. Radius is 1. 2 pi is the entire length around. Now tell me, how many radians are in an entire circle? 2 pi. So notice that the radians and the length are the same in the unit circle. It's part of what the definition is. So when it says find the terminal point on the unit circle determined by the following value of t, t equals pi over 4, here's what it's asking for us to do. If you look at your sheet that I gave to you guys, where is it? Where'd it go? There it is. Okay, pi over 4. Here's what it's wondering. It's saying, what is this length right here to this spot? Because little t in the unit circle is the same as theta, pi over 4 radians. Okay? At 45 degrees, what is the terminal point? What is that point at that spot? Square root of 2 over 2, square root of 2 over 2. That's all it's asking for. Okay? That's all it's asking for. So, I go back to my sheet, and I write down square root of 2 over 2, square root of 2 over 2. 4 pi over 3. I go over to my unit circle. You could construct it by hand if you wanted to, which I assume you can do after we went through this. And if we go to our unit circle, 4 pi over 3, that brings me all the way to right here. And what's the coordinate there? What is that terminal point? -1/2 and negative square root of 3 over 2. Very good. That's the terminal point for that arc length. Again, t technically represents arc length. It happens to be the same as theta in the unit circle. And t equals -5 pi over 6. So now I look at my unit circle and I go -5 pi over 6. Well, +5 pi over 6 would bring me to where? 150 degrees. So -5 pi over 6 would be 150 degrees in the opposite direction. -5 pi over 6 would be right here. And that would be negative square root of 3 over 2 and -1/2. And again, to do it by hand, all you would do is you would construct I don't care what you do for the assignment, but I mean, you know, if you have a quiz and I ask you to construct it by hand, I would expect you could go to that spot, show that it is a 30, 60, 90, and be able to figure out that this is 1, this is negative square root of 3 over 2, and this is -1/2, and be able to go that way. So what I just did there, if you could do that, you are A+ understanding for the day. So I go back to my sheet, and I write this down. Negative square root of 3 over 2 and -1/2 is my point. There I am. Okay. So define reference number. Last thing for the day, reference number. Shortest distance between the terminal point and the x-axis. X-axis, 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 not the y-axis. Notice when we draw our triangles, we're always drawing to the x-axis, aren't we? Because drawing to the x-axis tells us our height. Always the x-axis. Always. Common mistake made. So I want to find the shortest distance between the terminal point at 2 pi over 3 as well as the x-axis. So if we look at my unit circle and I look at 2 pi over 3, okay, 2 pi over 3 would be right here, okay? So is my shortest distance the blue or the red? The red, okay? And what is the distance between pi and 2/3 pi? 1/3 pi. The distance between pi and 2/3 pi is 1/3 pi. You may also think of it by saying, you know, what angle do I have left over there? I have a 60-degree angle, which is pi over 3, 1/3 pi. Now, if t is equal to, is that positive 4, does it say in your sheet? Okay, so t equals positive 4. Watch what happens when I do this. Okay, I'm going to draw this one out right here. Positive 4 radians. Well, that's not written in terms of pi. It's written as a decimal. So I'm going to write these as decimals. 0 radians, 3.14 radians. What would this be? 1.57 radians. Half of 3.14. And then this down here would be 4.71 radians. So if I were to draw a length of 4, t equals 4, if I were to draw a length of 4 around here, where would I get to? Which quadrant? Third quadrant. Right there, okay? Now, what length is shorter to the x-axis, the red or the blue? The red is shorter to the x-axis. It will account for this length right here. So that length is going to be the difference between 4 and 3.14. So what is that length going to be? 0.86. How did I get that? 4 minus 3.14 is equal to 0.86. That's that distance. Now, if you were all the way over here, what is 2 pi? 360 or 6.28. And we have time to do the last one. T equals negative 3.62. Again, I'm going to draw my graphic. Negative 3.62. This would be 0 or 6.28. This would be 1.57. This is 3.14. This is 4.71. If I were to draw, forget the negative, if I were to draw 3.62, which quadrant would I be in? The third. So negative 3.62 will bring me to the second. Okay? 3.62 would bring me down here to third, so negative 3.62 will bring me up to the second. Okay? All right? Negative 3.62 would bring me up to the second. So how far past 3.14 did I go? .6 or 3.62 minus 3.14 is 0.52. What? I'm sorry. What? Sorry. I went off of what somebody said over. Who said it? Alex? That's a reference point. So, let's review what you did. We reviewed finding a point on the unit circle, finding a missing point on the unit circle, converting radian measurement to degrees and terminal points, and we also then went over to using terminal point and length over here as well. Your assignment is here. Yes, you do not want to just let this sit and not practice it. One of the #1 practices that teachers could give you, all the research shows us, is an adequate amount of homework. That is what the research suggests. And here's the deal. Right now, it is on the working table, but it's not stored in long-term memory, you guys. This is not stored long-term memory. We want this to get to long-term memory. The only way that happens is for you to work on it and then for you to sleep. So when you work on it and then you sleep, your body actually then stores it long-term. So if you come Monday and you don't have this started, you're not in very good shape. This video will be online on YouTube for you to watch in case you forget part of it. But all these problems should model what we've seen. If you get confused on something, move to stuff you understand. Do not spend more than, 5-10 minutes working on something you don't know how to do. That won't help you. Okay? If you do that, you should be in very good shape and good to go.